Right. Today question actually it's from mechanics and heat as well. So it's a connected question. You need to find the theories that are connected. Right. So these type of questions are common from MCQ paper from 30 to 50 questions. So you need to practice this type of questions. You need to figure out which theory you need to apply. So here it's from mechanics and heat as well. Right. This is an easy question. So you can easily grab the point here, but still practice these type of questions and you will finally be able to find good questions. Right, the hidden theories inside good questions. So even if you could do this question, just go through with the video explanation just as usual, you will find something new. Right, let's get into the question now. Alright, let's get into the question. A metal sphere with radius r rotates around an axis going through its center. When the sphere rotates with n turns per second speed, it was stopped suddenly. If 50% of the total energy is converted and increase the temperature, find the temperature increment of the sphere. Specific heat capacity of the sphere is S. Right. Let's get into the question. It's an MCQ question. So now you can see this sphere is rotating around its axis with a speed n rounds per second. So let's find the structure of the question. They are asking us to find a temperature increment. So that's mc delta theta, right? And 50% of the total energy is converted into heat. So and it will increase the temperature as well. So 50% of the kinetic energy, 50% of the kinetic energy, 50% of the kinetic energy will be converted into this heat energy, and it will increase the temperature as well. Right, kinetic energy, half the kinetic energy and mc delta. This is the structure of the question. Remember that, right? When we are doing a question, we need to find the structure of the question initially. If you know the structure of the question, we can flow right through the question. Right, finding kinetic energy, that is half I omega squared. You should know that, right? Let's find the half I omega squared value and move forward. Then the kinetic I, moment of inertia of the sphere, is 2 by 5 mass squared. Omega, it's a tricky thing here. Now finding omega, right? The data they are telling us n number of turns per second. So one turn means 2 pi angle. So that into n, 2 pi n is omega value. So let's apply that value there. 2 pi n square, that is omega squared, right? And remember that 50% of this energy is mc delta theta, right? mc delta theta, right? Let's simplify it, half and half. Yes, we can get it as 1 over 4, then 2 over 5 mr squared. Again we get 4 pi squared n squared, right? ms actually delta theta, right? Let's simplify it now. This 4 and 4 cancel off, you can easily see that, and this m and m cancel off, s we can bring it down. So let's simplify and write it down properly. So we get 2 by 5 again r squared pi squared n squared divided by s 5s. So this is our answer for delta theta. Let's check our answers now. 2 pi squared n squared r first answer. We can see first 2 r squared pi squared n squared, 2 r squared. Yes, that's our answer. First answer is correct. This question actually it's not that difficult, but you need to remember couple of theories: moment of inertia of the sphere and how to find omega value from turns and all that, and 50% of the kinetic energy, and everything should be connected, right? If you are not able to do questions like this, you know what to do. You have to practice questions like this, find similar type of questions and practice, and you will finally be able to do questions like this. All right.